What are we doing today? Whoops, we are doing logarithmic properties. What are the properties of log functions? They're very convenient to know. They help you solve equations. Let's talk about them. First of all, let's refresh your memory about stuff you know. Okay? What do you know? Let's see. Hopefully you know something. Okay. Log, listen up. Log base, I don't care. Log base anything of 1 has to be what? 0. Why? Because you write that exponentially how? B to the? 0 is 1. That's why. Okay? Just checking. Some people got 100, right? So, okay. And log base, I don't care, to the same number is what? 1. Why? Because B to the 1 is B. Isn't it? Yes. I thought this stuff was tough. Okay, now, those are two very important properties of logs. Log of 1, any base, is 0. Log of B, the base, is 1. Any base, doesn't matter. There are infinitely many log functions. Log base 2, log base 3, log base 4, log base 5, log base 1/2, log base -2, log base E, log base 10, whatever. But they all have this in common. All right, that's going to come in handy. All right, what about this, though? Take a look at your Ziggy. And let's take a look at some log values. I'm going to make a table of logs. How about, let me use the ln key for fun. What's a log of 2? Well, you know what? I'm going to have this run off to 3 places for me. You know how to do that? Put it in fixed 3. Float means it'll put the decimal wherever it feels like. If you pick one of these numbers, it's going to fix the decimal such that it's rounding off to 3 places for you, or 4 places, or 5 places, whatever. So I'm picking fixed 3, not float 3. It's called fixed 3. And if you do the ln of 2, it'll round it off to 3 places for you. Okay? How do you do that? Go to mode, go to where it says float, and I don't want float, I want fixed 3. Hit enter, and it's highlighted, you're done. All right? All right, now what I want to do is compare some values of the log. It doesn't matter what log I'm using ln. Log base E of 3, remember ln is log base E? Okay, and the log of 4. And how about the log, let me compare all this to the log of 6. Can I get away with that? Yeah, it sort of folds off the screen, but there you go. All right, so look, that's the log of 2, huh? And that's the log of 3. Do you see any relationship to the log of 6? Just look at log 2, log of 3, log of 6. Is there a relationship? If you add them together, yeah, that's a good instinct. You're right. Now, this is rounded off, so if you add them together, it may not be exactly this, but it is, isn't it? Look, you get 12 carry the 1, 19 carry the 1, 7, right? So, let's write that down. That's interesting. It doesn't matter what base you're in, but I'm in base C, so I'm going to say so. ln of 2 plus ln of 3 is ln of 6. That's interesting. All right, take a look at these values again. Is there... Yes, where's my calculator? Calculator, come back. Hello? I lost my calculating device. Where did it go? This is most unfortunate. Wait, let me start it up again. Hang on. I know why, because I lost my internet or something. I can't get to my H drive. Ah, it's crashed. Oh, stupid computer. Oh, wait. Ah, yes. Okay. Now, look. This is log base 2. Do you see any relationship between log base 2 and log base 4? What do you think? Twice as much. All right, how about this? Log base 2 and log base 4 are related as doubles. How about log base 3, whoops, too many parentheses there, and log base, I don't know, 9? See relationship there? Is it triple? Double. It's also double. Log base 3 doubled is log base 9. Remember, there is round-off error here, right? So it's not exactly if you double this, but damn close, right? Do you see a pattern here? Log base 4 is going to be, if you double it, you're going to get log base, anyone see the pattern? 16. How about this one? Log base 2 is related to log base 8. Sorry, log base e of 2 is related to log base e of 8. 3 times. What's happening? Multiplying by 3, right? What does 3 have to do with 2 and 8? 2 cubed. Oh, all right, let's write that down. The log, let's see, let me make some room here. The log of 3 times the log of 2 is the log of 8. But realize that's the log of 2 cubed. We also saw that 2 times the log of 4 is the log of 16. Isn't that the log of 4 squared? You see a pattern going on? Isn't this the log of 2 times 3? What's going on? The log of a power is the exponent times the log of the base. The log of a power is the exponent times the log of the base. Interesting. What if I said, what is the ln of 27? What would you say? Yeah. ln, okay, I like that. ln of 3 plus the ln of 9. He's going back to this rule. The log of a product is the sum of the logs. Isn't this 3 times 9? Deanna, you can say? But isn't it also a power? Yeah. Log 3 what? To the third. No, not to the third, but you're on the right track. It's something to do with log 3. Yeah? Log 3 times log 3. No, it's simpler than that. It's 3 times log 3. Because look, can't you write this as a power? Isn't this a perfect square? So that's 3 squared. According to this rule, how do you ln, or any log, by the way, 3 squared? How do you ln 2 cubed? 3 ln 2. How do you ln 4 squared? 2 ln 4. How do you ln 3 squared? Nobody knows? 2 ln 3. Well, if I have 2 ln 3s and 1 ln 3, what's that? 3 ln 3. I could write it that way too. There's 2 rules running around here. This is a perfect cube. 3 cubed is 27, isn't it? How do you take the log of a power? You take the exponent, put it in front, times the log of the base. That's it. All right, so I've got 2 rules running around here. The log of a product is the sum of the logs. The log of a power is the exponent times the log of the base. Okay, that's good to know. How about this one? How are log base 2, log base 8, and log base, sorry, I'm saying it wrong, log base e of 2, log base e of 8, and log base e of 4 related? Are they?
What was the question?
How are log base 2, log base e of 2, log base e of 8, and log base e of 4 related? Those 3 numbers, yeah. Deanna?
Do you add log base 2 to log base 4?
To get log base 8. Yeah, that's true. The log of a product is the sum of the logs. The log of 2 times 8 is the log of 2 plus the log of, sorry, I said it wrong. The log of 8 is the log of 2 times 4 is the log of 2 plus the log of 4. But what I was after actually was something else. What's the log of 4 then?
Half of log base 8.
Yeah.
It's 2/3.
Is it half? Not exactly half. No, not right. But, okay, all right. Let's write what she said, and let me try and get to what I'm trying to get to. Yeah.
Or do you do like log of 8 minus log of 2?
Yep, that's it. What she said was, what Deanna said was the log of 8 is the log of 4 plus the log of 2, right? Yeah, I'm trying to get there. Hang on. Okay. All right, but what Alexa said was that the log of 4 is the log of 8 minus the log of 2. It's not the same statement. Is that the same equation, really? What did we do? We just subtracted ln 2 from both sides? But realize what this is. The log of the quotient, the log of a quotient is the difference in the logs. The log of a product is the sum of the logs. The log of a product is the sum of the logs. The log of the quotient is the difference in the logs. The order matters. The numerator has to come first, right? And the log of a power is the exponent times the log of the base. These are the three properties that every logarithm has in common. Plus, of course, what we said originally.